So today's focus is proportion concepts, meaning that we're going to look at proportional relationships and determine what causes a proportional relationship and what's not a proportional relationship. For this week, it is 3 lessons in Imagine Math. And again, it's just a suggested pace. So if you get behind, it's okay. Just know that I kind of got you doing about 2 to 3 lessons a week so that you can be done by the 30th. That is non-negotiable. You have to be completed by the 30th. Please remember to take your time on the lessons. You cannot fail a lesson more than twice. So please take your time on them. If you get to a point where you've already failed a lesson, log into office hours the next day and I'll help you out. Vocabulary for this unit, none of it is new. It is all vocabulary that you would have seen in 6th grade. So we have the additive relationship, that's where you're adding to your variable. We have the multiplicative relationship, which is when you have a coefficient in front of your variable. You have a rate of change, which is how you're changing as you go to the next value in the table. A constant of proportionality is same thing as a rate of change, but only when your values are proportional. A proportional relationship means that the 2 quantities vary directly with each other. So as I change one, the other one changes. And then a linear relationship is an equation that makes a straight line. And the formula that we're going to use for that is y equals mx plus b. There's a couple more out there that you'll use as you get older. All right, an additive relationship you used a lot in 6th grade. It's where it was the x is going up by the same amount each time. It's not related to the x value, or they don't directly coordinate. So every time you could add 4 pounds because of the backpack starts out weighing 4 pounds and then you add a constant amount to it each time. That is not a proportional relationship. A proportional relationship is more like when you go to the grocery store and you buy a fruit of some sort, like apples, it's like 99 cents a pound. If you buy 0 pounds, then you spend $0. Same thing with getting paid. If you work 0 hours, you're going to make $0. So it's that's considered a proportional relationship. So as this goes up, you multiply by the same value each time. So let's say you make $10 an hour. At 0 hours, you're going to make $0. At 1 hour, you're going to make $10. 2 hours, $20. Same type of scenario. All right, so you'll notice that this is probably a problem from your Imagine Math. So if you want to jot down some notes, now would be a good time. We want to look at these 4 scenarios and determine which one is proportional. Okay, so an airplane during takeoff, do you think that it's going to go at a constant speed at takeoff? Probably not. It's going to gain speed as it goes up. Your speed while riding a roller coaster, is that constant? Do you always stay at the same speed, or does it increase as you go down a hill and decrease as you go up a hill? So that's not a proportional relationship. A ball that's tossed up in the air and falls back to the ground, do you think it maintains a constant speed as it does that, or do you think it slows down as it gets to the highest point and then speeds up as it goes towards the ground? And then a car that rides at a constant rate of speed at 25 miles per hour for 8 minutes. They gave you the key word there, which is constant. So that's the constant rate of change, making it proportional. All right. So we're going to sort these and determine which ones are proportional and which ones are not. And I can't drag them, so I'm just going to draw arrows. So distance and time. Is it going at a constant rate of change? So like as this is changing here by 2, is this is changing by what? 4. And this is changing by 4. And this is changing by 2. So it does have a constant, But if I multiply, let's see, 4 divided by 2 equals 2. If I multiply this times my x value, does it give me my y value? No, it does not, because 2 times 2 is not 10. So it is not proportional because it does not go through the origin. It has to go through the origin to be proportional. Since I just said that, see how that one goes through 0, 0? That one is going to be proportional. And I'm going to change my color so all my arrows don't drive you crazy. All right, so a subway train that makes 4 stops in 12 minutes. 4 stops in 12 minutes. So it could make a stop every 3 minutes, but did it tell us where it started? It didn't. So this is going to be a non-proportional relationship. Okay? An elevator that stops at each floor for an equal amount of time. Well, did they tell us where the elevator started? Is that going to be a proportional relationship? No, it is not. It has to go through 0, 0, meaning I have to know that at 0 minutes, it will be at 0 distance. A car driving at a constant speed. The constant speed right there tells you that it's going to be proportional. And then a person hiking up and then down a mountain. Well, they didn't give us a speed. They didn't give us a starting point. They didn't give us an ending point. They didn't really give us enough information to figure that one out. I am going to... The points on this graph represent a relationship between x and y values. Which statement about the relationship is true? Okay, so let's look at this graph. They didn't really give us a lot of details, but you can kind of see the line. Sorry, it's not totally straight, but I did my best. Does it look to be proportional? No, because it does not go through the origin, which is 0, 0. It has a y-intercept right here where it crosses the y-axis, and that's a problem. So it's not proportional. So this one's out, and this one's out. Okay, so we know it is not proportional, which leaves these two choices. And what did I say it has to do every time? It has to go through the origin. So that's going to be the one we choose. It doesn't matter if your x and y values are whole numbers or not. That has no effect on whether or not it's proportional. Okay. And then one more. We're going to drag the situations and tables to their proper location in the table. I'm just going to draw arrows because I can't drag and drop on this screen. It costs a company $4 to make each t-shirt. Does that sound proportional? It's $4 per shirt. If they don't make any shirts, how much do they spend? $0. So that one is proportional because it goes through the origin. The equation for that one is going to be $4 per shirt. So you're going to multiply 4 times the number of shirts. And then, yes, we discussed it's proportional because it goes through the origin. Which means Lindsay's brother is 4 years older than her. So when Lindsay was not born yet, her brother was 4. After Lindsay turns a year old, her brother is how old? 5. So that is going to be this one. You don't multiply Lindsay's age times her brother's age because that would not work. And it is non-proportional. All right. Any questions? Awesome.